This is my latest project. I just finished it last night. I just want to show everyone that not that every attempt is a right attempt. You know, sometimes you make things and then, like for instance, I printed this in solid and it started lifting and all that, and it's just basically a waste of time and waste of material, but it's okay. Mistakes are very good to learn from. So then I designed I kept the same design, but I put just a 20% fill, and it's strong enough. It probably 10% fill will be strong enough for this project. So what this is as you can see, there's a counter in here, and you can really zero it out, and it doesn't always look perfect, but it's zeroed out. Let me try it one more time. There we go. So now we have all zeros. As you can see, it's made in China. I bought it some time ago so I can make coils, and I experiment a lot. And while I was using this system, which was just two pieces of metal that I recycled from some project, I also put ball bearings. Let me show you how I did that. So ball bearing like that, and then I put this aluminum piece so it's pushing on the center only, and then the other ball bearing goes here. And unfortunately it was catching and wobbling, and the reason being is because this thread here it's just too loose on this thread, and so I had to go back to the drawing board. And what I did is I put two ball bearings on one side and two on the other side. I had to put a washer between this one and this one that is smaller than the outside diameter, so it kept pushing on the center part of the ball bearing, because that's what makes this thing spin like that. Anyway, and as you can see, it's fairly loose, but not horribly loose, because you want to keep the tension between the coil you're making and between the spool that you're using to make the coil. And this is just a spacer or an insert for things that have a big diameter like this. And then I put these two cones. I designed these, this one much larger, this one smaller, two identical over here but shorter. And they look like this before I cut them a little shorter. But this particular one is left at full length, and so I have a spare one in here. And I use these ball bearings and pieces of recycled things like this, and this rubber piece also as a spacer. So when I need to use a spacer to move this back and forth, I have different length, as you can see. I'm leaving this long one over here for a couple of reasons. One, it doesn't fit in my little box. Second of all, it's I'm going to cut this off probably down the road, but I find out that it's handy to have when I need to like slow it down or speed it up, and so I can put like my finger on this. Okay, so this container here is going to hold all the spacers and all the extra pieces, and then this is going to go back to my parts box. And the way it works is very simple. I take a wire from here, put it up there, leave a little lead out, use a little electrical tape so I have long enough lead, and then you guide the wire left and right nicely tight. If you don't make it too tight, you're going to lose the power that this can actually deliver, and so you have to be a little bit careful. But otherwise than that, it was not that big of a project. I was planning to put a motor on this because it has a spool and a bracket for it, or whatever you call the spool, and I can put it like a little rubber band in over here, and then a foot switch. But these little coils like I'm making they don't really need that. Now, I don't make coils every day. If I was making them every day, this whole thing would be probably completely different looking, and I wouldn't buy this cheap Chinese Gizmodo winder. And but that's all that is to this little project that I just finished last night. And then I like to mount some small tools like this one. I like to mount it on a piece of board, a little scrap, and I will add feet, rubber feet, and so is this has rubber feet. That way it stays on your table and it doesn't dances around. And having these little saws, you're going like, well, what is it good for? Well, what I did is I reversed the blade in here, and then I cut plastic with it. And when I need to cut something like wood or different types of plastic, I can flip this right away back, so it's not that big of a deal. There's a little pusher. The only thing I wish that they made on this pusher is to put it also on this side, but in here it catches the blade. So what I'm going to probably do is improve it by milling in a little oval shape hole instead of just a drilled hole, and make it so it's adjustable left to the right a little bit more. And that's really easy to do. What you do is you just basically take a drill, drill a couple of holes right next to this hole in a material, so then you'll have basically 2 8s, like a symbol of an 8, and then I use the chisel to chisel out file out whatever the drill bit couldn't excavate. So these are kind of two little tiny projects that I figured out how to do. This one was super easy, of course. This one was a little bit more because I had to design this in Fusion 360. By the way, Fusion 360, you can download it from the internet, and they let you use it for free, and it's almost a full-blown version of the very expensive Fusion 360 program. So you can do even modeling in it. But I'm not a very good user at it, but I managed to make these pieces, you know, a little bit learning, but no big deal. Anybody can learn it. There are very good teachers on the internet. So that's all I wanted to show today. You have a great or fantastic day.